A CRC is a redundancy error technique. In the last bit, there is no variation in my data bit, so I'll write it 0. The functionality of the CRC checker is similar to the CRC generator. I want to calculate the appending 0 bits. Hello to all, welcome to my new session. I am Revati, faculty, Department of Computer Science, Vidhyaashram, 1st grade college, MYSURU. We are on the 5th session of digital to analog. Before going to start my session, I want to recall the things what I covered in the last session. In the last session, I discussed checksum. So what is checksum? Here, name itself indicates that check your sum. So, think that I want to send hello message. I want to send hello message. So, in transmission media, whatever the data I'm going to send, that is converted into digital form. That is in the form of zeros and ones. So think that I have converted this hello message into zeros and ones. So this is the actual digital form of hello message. So according to the checksum protocol, whatever the data bit I have, I want to divide that one into number of, that is equal number of ends. So for example, if I consider this example, how many bits are there? That is 1, 2, 3, 4, 5, 6, 7, 8. So it is total 8 bits. So now what I will do? I am going to make it 2 parts. So it is 8 by 2, it is 4. So one part contains 4 bits and another part includes 4 bits. Dear student, I will write it as 0, 1, 1, 1. In the next half, below I'll write 0, 1, 1. According to the checksum, what is my first rule? I want to divide the number of bits into n number of checksum. So, initially I did that one. Now, I want to perform addition operation. That is, I want to perform binary addition. For that, just remember the thing 0, 0, it is 0. 0, 1, it is written as 1. That is 2, number 2, it is 1, 0. And for 3, it is 1, 1. So, what I want to do, this one for your reference. But here, actually, I want to perform binary addition. So, if I add 1 plus 1, what's the value I am going to get? It is 2. So, how I can able to write? It is 1, 0. In binary, 2 is written in the form of 1, 0. So, what I will do? I am going to place 0. Then, I am going to place 1. That is carry. Carry for my next bit. So, now I have how many ones here? Now, I have 3 ones. For 3, that means number 3, how it is written? That is 1 and 1. So what I will do? I am going to write below 1 as it is and I am going to write carry 1. Now I have 1 plus 1, it is 2. How it is written? Once again 1, 0. So what I will do? I am going to write 0 as it is and I am going to move, that is carry here. So it is once again 1, 0, 1. So this is my actual sum. According to the checksum rule, I want to take the ones complement of sum. So this is my sum. So in ones complement, 0 is written as 1 and 1 is converted into 0. So this is the ones complement rule. So here I have 0. Suppose if I take ones complement of 0, then I'm going to get 1. If I take ones complement of 1, then I'm going to get 0. If I take, dear students, if I take ones complement of 0, then I'm going to get 1. If I take ones complement of 1, I'm going to get 0. Now, I want to append this checksum value, with the original data. What is my data here? It is 0, 1, 1, 1, 0, 0, 1, 1, and I'm going to add or append my checksum value 0, 1, 0, 1. So this is all done in your sender side. After finding checksum, you're going to append your checksum with your actual data. Then you're going to send it to the receiver. In the receiving side, same thing. So in the receiving side, what the receiver will do? The receiver is going to extract all the bits. He or she is going to divide the given data bits into equal number of n bits. So what is first my bit? 0, 0, 1, 1. 0, 0, 1, 1, 1. Then what is my checksum value? Here it is 0, 1, 0, 1. Now I want to perform binary addition. So count this one. So I have 3 ones. How I can able to write? That is written as 1, 1. So I'll write 1 as it is. Okay. Then I'm going to write another one as my carry. So if I add 3 ones, once again 1. So I'm going to place 1 carry here. Once again 1 and 1 carry. Once again it is 1. So what is my checksum here? It is 1, 1, 1. What is my next step? I want to take the ones complement of this value. So if I take ones complement of this number, then I'm going to get 0, 0, 0, 0. So if the received or calculated checksum is 0. I repeat, if the calculated checksum is 0, then it indicates that there is no error or there is no modification in the data whatever they received. If the calculated bit value is 1, then it indicates that whatever the data they have received, that is modified. So no need to accept the data, reject. So this is all about your checksum. But today's session, we are going to discuss cyclic redundancy check. This is also one type of error detection method most commonly used in network. So a CRC is a redundancy error technique where checksum is also based on the redundancy. But here this CRC is also based on the redundancy error. So to calculate CRC, we have to perform certain steps. We have to perform certain calculation. So in both the side, sender and receiver must agree upon their transmission data pattern. So in the sender side, the sender is going to generate CRC bit. But at the receiving end, the receiver is going to validate the CRC, that is cyclic redundancy check bit. So The technique follows certain protocols. So, in CRC technique, a string of zeros is appended. I repeat, in CRC technique, a length, that means string of zeros, is appended with actual data bit. Consider the example. Suppose if you have 1001 as your divisor, then you want to add, how many bits are there here? Here it is 4. So you want to add 4 minus 1, that is 3 bit to your actual data. So here this is your divisor. So consider the example that this is my actual data. So what is the length of my data? It is 5 bit. Okay, then what is the length of the divisor? Here it is 4 bit. But I want, according to the CRC rule, I want to append zeros at the end of actual data bit. So what is the formula to calculate? That is the total length of your divisor minus 1. So what is the length of divisor? It is 4. So 4 minus 1, it is 3. So what I want to do? I want to add 3 zeros. So this is my first step. Then secondly, the newly extended data is divided by the divisor. So the second step is the newly extended, the data bits are divided by this divisor. So initially, what is the first step? I want to append zeros in the beginning of your actual data based on your divisor length, that is divisor length minus 1. Then in the next step, you're going to divide your actual data with the divisor. What is the third step? The CRC reminder replace the appended zeros at the end. That means after calculating CRC value, you want to replace whatever you appended zeros values with the newly calculated CRC value. In the receiving end, same thing. The receiver receives the data and follows, that is followed by the CRC reminder. That means in the receiving side, the receiver is going to receive the data with CRC bit. The receiver will treat this as whole unit, as single unit, and it is divided by the same divisor. So in the receiving end, the whole data is considered as single bit and it is divided by divisor once again. If the result of the division is 0, I repeat, if the result of the division is 0, which means there has no errors. That means there has no data modification. Else, there is a data modification. So here, if the resultant of the division is 0, then it indicates that there is no alteration in the data bit. So accept the data bit. Else, reject the data bit. So if the resultant of the division is not 0, which means that the data consists of an error, therefore the data is discarded. In CRC generator, so this CRC generator is done in sender side. So these are the sender side activity. So what I want to do at the beginning, I want to calculate the appending 0 bits. So what is the first thing I want to do here? What is the first step? Add or append 0. append 0 to actual data. Then how to find the length of the 0? That is based on your divisor. So divisor minus 1 equal to the total number of bits what you want to add in your data bit. Dear student, then perform binary division. So here binary division is nothing but your XOR operation. Then store the value whatever you are going to get after performing division, that must be stored in CRC. So this is the actual procedure. So consider this example. So what is the data I have? Data bit, that is 11100. So this is my original data bit. So what is my divisor here? It is 1001. Okay. So now I want to append zeros to my actual data bit. So how to find the 0? The length of the 0 is calculated by using the formula, that is divisor length minus 1 equal to the total number of 0, that one you want to add in your actual data bit. So what is the length here? It is 4 minus 1, it is 3. So here I am going to place 3 zeros. So here I am going to place 3 zeros with my actual data. Now I want to perform binary division. For that, just remember it is XOR operation. So XOR of A and B. So here A, it is B, here it is XOR. Here it is XOR. So what are the possible values? I am going to get 0, 0. What is the output? Here it is 0. 0, 1. If any one bit is going to vary, then the result is 1. So the next it is 1, 0. What is the result? I'm going to get 1. Suppose the next bit is 1, 1. So both the bits are same. So I'm going to write it as 0. So this is the truth table of your XOR gate. So suppose if I am performing binary addition, then I want to think that I'm going to perform XOR operation. So it is 1s are 1, 0, 0, 1. 1. So see this one, 1, 0. So there is a variation in my bit. So I will write 1 here. Consider second one, same thing. There is a variation. So I'll write it 1. The next one, there is a variation. I'll write it 1. So in the last bit, there is no variation in my data bit. So I'll write it 0. Next time, I'm going to get this 0. So I'll place it here. So 1s are, once again, it is 0, 0, 0, 1. So what is the value I'm going to get? Once again, same value, 0, 1, 1, 1, 0. So I'm going to bring this one here. So once again, 1, 0, 0, 1. So 1 value, 1. So 0. Now I'm going to bring 0 here. Once again, 1, 0, 0, 1. It is 0, 1, 1, 1. So I'm going to get another 0 here. It is 1, 0, 0, 1. So it is 1 1 1. So this is my CRC value. So the last value, the whatever the value I'm going to get, it is my CRC value. So what I will do, I'm going to append this CRC value with my actual data. So here what I will do, so what is my data here? 1 1 1 0 0, and these three are my appended value. So now I'm going to replace this appended value with my new value. Okay, that is my new CRC value. So it is 1 1 1, and I'm going to send this one to receiver. So this is my actual data now, and I'm going to send this data to my receiver. So this is the actual data. Along with actual data, I'm going to add CRC bit. In CRC Checker, same thing, same procedure. The functionality of the CRC Checker is similar to the CRC generator. I repeat, the functionality of the CRC Checker is same as CRC generator. When the string, this is the actual string, is received at the receiving end, then the CRC Checker performs the modulo division 2, that is binary division 2. A string is divided by the same divisor, that is 1001. Now in this case, CRC Checker generates the remainder of 0, then the data is accepted. That means at the end, after generating CRC, if the CRC bit is 0, here 0 indicates there is no error, there is no modification in the data, so accept the data. If there is any variation, that means instead of 0, if it is 1, then it indicates that there is a modification of data. So reject the data. So let's see the procedure one by one. So what is the actual data the receiver is going to receive? That is 1 1 1 0 0, and this is my CRC number, CRC bit. So what is my divisor? Once again 1 0 0 1. Once again same XOR operation. So in ones it is 1 0 0 1. Perform XOR operation. So it is both the bits are varies. So it is 1. Here both the bits are varies. Here it is 1. Once again both the bits are varies. So it is 1. So if both the bits are same, then it is 0. Now I'm going to bring 0 here. Okay. Then once again it is ones. I'm going to get 1 0 0 1. So look at this bit here, both the bits are varies. So it is 1, both the bits are 1. So here 1 0, it is 1. Here 1 0 1. Here 1 1, it is 0. So what I will do, I'm going to bring 1 here. Now what is my divisor? It is 1 0 0 1. So 1 1, it is 0 1 1, it is 0. Now what I want to do, I want to bring this one here. So ones I'll write 1 0 0 1. So same bit I'll write as it is. Same bit 0. Here it is 0. If it is 1. So what I want to do, so bring this 1 here. It is 1. So 1 ones are 1 0 0 1. So my CRC bit, what is my result here? My result is 0. So this is the calculated CRC. Now what I will do, I'm going to place this CRC. I'm going to replace this CRC with my calculated CRC, that is 1100, and this is my actual data. So dear students, this is my actual data. So now I'm going to compare my CRC field. If the CRC field holds 0 value, then there is no modification in my data, so it is accepted. If there is any modification in my CRC value, then it is rejected. Dear students, let's see the example. Same example I have explained till now. So here CRC is mainly based on redundancy. CRC value is calculated mainly based on redundancy. So what are the steps both the sender and receiver must perform? In sender side, sender is responsible for generating CRC. Whereas in receiver side, the receiver is responsible for validating CRC. The steps comes under CRC generation is, for example, consider that I want to send one data. Okay, this is my data, that is hello. So before going to send the data, this data must be converted into some digital form. So I'm going to convert this one as my digital form. So this is the converted data. Now in CRC, the CRC generator is going to add 0 to the end of your actual data. So to add zeros, how the zeros are calculated? Based on your divisor value. For example, consider this is your divisor value. So how many bits are there in your divisor? It is 4. 4 minus 1, it is 3. So I'm going to place 3 zeros to my actual data. Now I'm going to perform binary division. So binary division is same as your XOR operation. After performing binary division, whatever the value I'm going to get, that is treated as your CRC. Suppose if I am performing division operation, then I'm going to get two values, that is quotient and remainder. Dear students, please remember that to calculate CRC, whatever the value we are going to get as remainder, that is your CRC value. So in the next step, what the sender will do? Sender is going to replace these zeros with calculated CRC, and sender is going to send the data to receiver. In the receiving end, what the receiver will do? Receiver is going to receive the data and receiver is going to perform binary division once again. So for there also same procedure, same step you're going to consider, and at the end you're going to get CRC. So whatever the result you're going to get as your reminder, that is your CRC. So the received, that means calculated CRC is equal to 0, then accept the data. That indicates that there is no modification in your data. Suppose if the calculated CRC is 1, then that indicates that whatever the data you have received, that is modified during the transmission. Here you studied what is digital modulation, then at the same time you studied transmission methods. In that transmission method, we studied synchronous and asynchronous. Then we studied errors, error control and error detection. So what are the errors? usually it is going to occur. That is single bit error, burst error. Then we studied different error detection techniques like parity, bit checker, checksum, then CRC method. In my next session, I'm going to deal with goals of layered protocols. I repeat, in my next session, I'm going to cover goals of layered protocol. This is the separate chapter, comes under your second unit. Dear students, in my today's class, we studied CRC. So, I hope you got more information about error detection technique. I hope you enjoyed my session. Thank you for watching my session. Let's meet in the next session. Until then, take care. Thank you.